Hello, welcome to Edu Paragon TV. My name is Adeyemi. Today we are going to be talking about variation. There are actually four types of variation, and we will take them one by one. Before we go ahead, I would like you to subscribe to this channel and like our video. Hit the notification bell so that you get more of such videos as this. So like I was saying, four types of variation. You have direct, inverse, or uh, indirect. Then you have joint and partial variation. One by one, we will treat this. But for today, we are only going to talk about direct variation. Variation. The first thing we want to do here is to define variation. And what is variation? Variation can be explained as a relationship between two or more quantities. Now, when we are talking about quantities, we are talking about things that you can count, you can measure, you can put measurement to. For example, your age, you're talking about money, weight, length, and things like that. This relationship shows the change in one quantity that leads to change in other quantity or quantities, as the case may be. So there are four categories. Number one, direct variation. That is what we are going to deal with in this video. Number two, indirect variation, or what you call inverse variation. Number three, joint variation. And four, partial variation. So we move ahead now to direct variation. All right, so what is direct variation? What is the understanding behind it? In direct variation, increase or decrease in one quantity leads to proportional increase or decrease in the other quantity. For example, if you have 3 cupcakes and they cost 15 naira, then 5 cupcakes will cost 25 naira. Now, if you notice, when the number of cupcakes are increased, sorry about that. All right, it are increased. You see that the amount also increased. Now, in the reverse, if the number of cupcakes should be reduced, then the amount also will be reduced. I have a simple diagram that explains this. As you can see, an arrow coming up. Let that arrow represent quantity A. All right, so we have another arrow representing quantity B. Okay, so this two shows that as quantity A is going up, quantity B is also going up. In the other side of it, if quantity A is coming down, as we are going to see now, all right, you also see quantity B also coming down. Now, this is a simple diagram that explains the way direct variation behaves. So the two put together is simply regarded as direct variation. So with this background, we are safe now to go ahead and talk about direct variation proper. Before we go ahead to talk about direct variation, it is important for us to take note of two important symbols that we are going to use. And the first one is the symbol of proportionality. That is meaning proportional to or varies directly as. And number two symbol to be used is letter K, meaning constant of proportionality or constant of variation. So this symbol is used, yes, the letter K, I mean now, is used to replace the proportional sign when equal to is introduced in the course of the solution. That happens because variation is not an equation. So you can't just go ahead and solve it. You have to convert it to an equation. And in doing that, you introduce equal to sign and remove the proportional sign and put k, which means constant of proportionality. So let's see an example of how variation is written. If y varies directly as x, then it is written as y proportional sign x, which is read as y varies as x. Then y is equal to kx. That is when you are converting it to equation. Let's solve example 1. Let's get to see the question. If y varies directly as x and y is equal to 5 when x is 2, find the value of y when x is 8. The first thing we need to do here in our solution is to simply, first of all, find k, our constant of proportionality or constant of variation. Anyone you call it is okay. So we write our expression y is proportional to x. Then converting it to equation, it means y is equal to kx. I told you, you introduce equal to sign, then you remove the proportional sign and bring in the constant of proportionality. So with this, we now go ahead to solve to find letter k, our constant of proportionality. Now we have been given in the question that y is equal to 5 and x is equal to 2. So all we need to do is to make substitution. Where we see y, we put 5. Where we see x, we put 2. So that means 5 is equal to 2k. 5 is equal to 2k. So how do we find k? We simply divide both sides by 2. Divide both sides by 2. And when you do that successfully, you are going to have 5 over 2 is equal to 2k over 2. And 2 can divide 2 to give you 1. So in that case, we say k is equal to 5 over 2. So we have successfully found k. And let me emphasize that it's important for us to find k, which is our constant of proportionality, because it is what will lead us to our final destination for the solution that we are actually working at. So we move ahead now. To now find y when x is equal to 8, we quote the equation again, y is equal to kx, and then we do substitution. X, we have been told, is 8. Then wherever we see y, wherever we see x, we just put 8, following the equation that we have here. So that gives us y is equal to 5 over 2, 5 over 2 being the value of our k, and 8 being the value of x, the new value of x given to us. And 2 can divide 8. That will give you 4. Then 4 times 5, you have 20. So we have solved the first question. Let's try another example. All right, example 2. Let's see the question. If P is directly proportional to Q, A, find the constant of proportionality. Now, in this case, we are being told to find K, but normally we will always find K, because without finding K, we cannot be able to progress in our solution. So find the constant of proportionality if P is equal to 16 and Q is equal to 4. B, find the relationship between P and Q. And C, what is the value of P when Q is 24? we are going to look at this. Of course, our first solution is A, to find constant of proportionality. So let's express our variation statement, which is P varies as Q. Then P is equal to KQ. Of course, we know the value of P to be 16 and Q to be 4. Then we do our substitution. Then we substitute. So that simply means 16 is replacing P and 4 is replacing Q. So we have 16 is equal to 4K. So divide both sides by 4 in order to find K. And so that will give us 16 over 4 is equal to 4K over 4. Of course, 16 divided by 4 will give 4, and 4 divided by 4 will give 1. So we have K is equal to 4. So with this, we have found our constant of proportionality, which is letter K. So we go ahead to solve the B part of the question. All right. So the B part says we should find the relationship between P and Q, and that is simply 4P rather is equal to 4Q. P is equal to 4Q. Now, let me explain this relationship. It simply means that for every Q, every P, Q is increased 4 times. So if we have 2P now, it will simply mean that you are having 8Q. If you have 3P, it simply means that you are going to be having 12Q, and it goes on like that. And that is the proportional increase that we are talking about. And let's solve C now. So to solve C, we are asked to find P when Q is equal to 24. So since Q is given to us, we just return to our equation, which is the relationship between P and Q. P is equal to 4Q. And we substitute. Very simple. P is equal to 4 times 24. Q being 24. So if you do that very well, we are going to have P is equal to 96. With this, we have come to the end of the class for today. But before we go, it is my wish that I give you some activities to try on your own. And of course, leave a comment in the comment box to know your experience about these questions. What are your challenges? And I will interact with you. We will get to understand each other. I'll give you further explanation as the case may be. So, like our channel, share this video, let others get to know about it.